Hey guys, and welcome back to this class. In this lecture, we're going to continue our e-commerce example. If you don't want to code along, just go to GitHub and look at the file logisticpredict.py. So the first thing we need here is a way to get the data. So we're going to import from process, get binary data. Okay, and then we're just going to call that function and assign it to the variables x and y. Once we do that, we can get the dimensionality of the data set, which is x.shape1, and we can use that to initialize the weights of our logistic regression model. So that would be np.random.randn of size d, and then b is the bias term, so that's a scalar. We're going to create functions to do our predictions. So we need a sigmoid. That would be 1 divided by 1 plus np.exp minus a. And then we're going to need a function called forward. So that's going to take in x, w, and b. And it's going to return the sigmoid of x.w plus b. Once we have that, we can call forward. We can assign it to a variable called p of y given x. So we pass in x, w, and b. And then we can make predictions. So that would be rounding p of y given x. Next, we can write a function to determine our classification rate. So it's a function called classification rate, and it takes in the targets and the predictions. And it's going to return np.mean y equals p. So this looks like it would return an array of booleans, but that actually returns ones and zeros. So effectively it will divide the number of correct by the total number. The last thing we'll do is print the score. So that would just be calling classification rate. We pass in y and we pass in the predictions. Alright, so let's run this file. Alright, so you can see that if we choose the rates randomly, we're not going to do that well, about 32% accuracy. Next, we'll look at how to train these weights so we can get this score more accurate.